Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss how to delete the nodes from the circular linked list. So I request everyone to watch the complete video for better understanding. So what is meant by deleting a nodes in the circular linked list? We have several nodes in the circular linked list. Why we are calling it as a circular linked list? If you look at here, the last node consists of address of the first node. So it is forming a circle. And it is a single linked list. Why I am saying it is a single linked list? If you look at the node structure, I can say that it is a single linked list because each node will have the data and address of the next node. Whereas if it is a double linked list, it will have the address of the previous node, data and address of the next node also. So it is forming a circle and it is having a node structure of a single linked list. We can call it as a circular linked list or circular single linked list. Now, what is meant by deletion? We have several nodes. Now we want to delete a particular node. Now, what are the cases or the scenarios we can discuss about the deleting a node from the circular linked list? One is that deleting a node from the beginning. Is it clear? Now you can ask me, sir, it is a circular. What is the beginning? The node which is pointing by the head, we will call it as the first node. And the node which is pointing by the tail, we'll call it as a last node in the circular linked list. Similarly, I want to discuss how to delete the last node in the circular linked list, or if user specified that he want to delete from a specified position. Suppose let's take that he want to delete the second node or he want to delete the third node, then also he can give. So we will discuss these three scenarios in detail: deletion a node from the beginning, from the end, from a specified position in a circular linked list. Now, let me discuss how can we delete a node at the beginning. So, let me write the user defined function called void delete at begin. Okay. Now, when we are deleting a node from the beginning, first thing we need to check whether the circular linked list is empty or not. If the circular linked list is empty, how can you delete a node? It is not possible. Am I right? So, how we will do is that if head is equal to null, then you can printf list is empty. Else, if list is not empty, meaning is that some elements are there in the linked list, or I can say that some number of nodes are there in the circular linked list, then how can we delete a node from the beginning? Now let me discuss what are the steps we need to follow. Look at here. The node which is pointing by the head, we will call it as a first node. So this node I want to delete. If I need to delete this node, okay, I need a pointer which is pointing this one. Why I need a pointer? Because I need to release this memory. And another thing is required is that the head should be pointing to the next element, because once you delete this node will become the first node. And then tail of next should have the address of this node. So these are the steps you need to follow when you are deleting a node from the beginning in a circular linked list. So to do that one, I will create or I will declare one pointer called temp of struct node type, and I will initialize it with the head. Is it clear? I am initializing it with the head. Now look at here. We have declared a temp which is a struct node pointer. It can store the address of a node. Now look at what value is there in the head. It is a 100, which is the address of the first node that you are storing here. Is it clear? Now temp is pointing to the first node. Now what are the steps you need to do? First thing you need to do is that you need to move this head to this position. So what I will do is that I will write it as head is equal to head of next, or you can write temp of next also, anything. Now what is head? Head is 100, head end of next is 200, that you are assigning to the head. So now you will get 200 here. So now this head pointer is pointing to the second node in the circular linked list. One task is completed. Now what you have to do? You have to write here tail of next is equal to head. Okay, look at here. tail of next is equal to head. Now this will be the first node. Am I right? So here it should have the address of this node. So if you write 100, it will be pointing to this node. If you write 200 here, this node will be pointing to this node. Is it clear? Now what you have to do? You have to write temp of next is equal to null. Why? You have to release this link, or you have to delete the link from node 1 to node 2. Okay, so what I will write is that not tail, it is temp of next. Temp of next is equal to null, because now this node is pointing by the pointer called temp. So you have to write temp of next. Here you are specifying, which is equal to null. So you are assigning here null value. If you assign the null value here, the link will be broken. Is it clear? Now this node is alone. Okay, now you can release it. How can you release? You can use a function called free, and you can give the pointer which is pointing to that location. So you are writing free of temp. So this memory will be released. Okay. Now look at here what the temp is consists of. Temp is consists of an address of a non-existing memory, because 100 memory you have released. Now what it will call? A pointer which is pointing to a non-existing memory, we'll call it as a dangling pointer. We should avoid the dangling pointer problem. So how can we avoid? We can assign the null value to that pointer. So now temp will consist of null. Now this temp is acting as a null pointer. What is a null pointer? A pointer which is not locating to any memory location. We will call it as a null pointer. So temp value is null. It is not pointing to any memory location. This is okay instead of dangling pointer problem. So let me close the else, and I will close the function. Is it clear? Are you able to understand? If you want to call again, okay, delete at begin. Now again you will check the condition. Head is equal to null. No, head is 100. Sorry, in this case now 200. 200 is not equal to null. So this case will be failed. If this condition is failed, this statement will not be executed. It will come to the else block. Now what are the steps we are doing? Strut node star temp is equal to head. Now head will consist of, or temp will consist of 200. Okay, is it clear? Then what it is? Head is equal to head of next. Head is 200. 200 next is 250. That you are assigning to the head. Now head is pointing to this node. Which node? This node. Temp is pointing to this node. Then what you call? Tail of next is equal to head. Tail is pointing this one. Tail of next is this one, which is head. So now you will get here 250. So this link has been broken. And now this link has been established. Then what you are doing? Temp of next is equal to null. Temp is this one, of next is this one. You will assign the null value here so that this link will be removed. You will get null. Then what you have done? Free of temp. So this memory will be released. Now it is becoming as a dangling pointer problem. To avoid that one, we are writing temp is equal to null. We are assigning null value to the pointer called temp. This is a good way of writing the program. Is it clear? Lot of people will stop up to free of temp. They will not write this temp is equal to null. But if you want to be a good programmer, you should write these steps also. Okay. So this is about deleting a node from the beginning in a circular linked list. Now let me discuss how can we delete a node at the end from a circular linked list. To do that one, let me erase this entire part. Okay. Okay. I should have not erased everything. Anyway, I will write it for you. Don't worry. I should have used some of the existing code. Anyway, by this time you would have liked my video. Please press the like button. Share the video with your friends. Now, let me take a simple example. We have 4 nodes. 100, 200, 300, 400 locations, 10, 20, 30, 40 is there. Okay, this will have the address of next node 200, address of next node is 300, address of next node is 400, address of the next node will be 100, so that it will be acting as a circular linked list. Okay, then we will have two pointers, one is head, another one is tail. Head will be pointing to the first node, so it will have the address of the first node will be 100, address of the last node will be 400. Now you want to delete the node from the end, so this node you want to delete. Okay, to do that one, is it clear? Once you delete this node, what are the things will happen? There should be a pointer which is pointing to this node. Tail is a pointer which is pointing to this node, so you can call free of tail. Okay, good. Then here what are the things you have to do? Now you have to write some pointer here. That pointer next should have the head. So you need one pointer here, one pointer here. Why you need one pointer here? Because here you have to write the 100, which is the value which is there in the head. So that now this node will be pointing, because once you release this node will become the last node. So last node address next will consist of first node address. So here 100 should be there. Am I right? So we need two pointers. How can we create the two pointers? Already we have one pointer called tail. You need another pointer pointing up to here. Is it clear? So how I will do? Please watch it. I will write a user defined function called delete at end. Why I am writing void here? Meaning is that this function does not return any value. Okay, again you need to check head is equal to null, then list is empty. If list is empty, how can we delete the elements? That is not possible. Am I right? Else, if list is not empty, how can we delete the last node? Now we will discuss. We will create or we will declare one pointer called temp, and we will assign it with head value. So let me write it here. Now we have declared one pointer called temp. We have assigned whatever the value which is there in the head. Head is having the value 100. Now temp will consist of address which is 100, which is the first node address. Okay. Now what you need to do? You need to travel up to here, last but one node. So how can you do? We will write while temp of next not equal to tail. Then what I will do is that I will write temp is equal to temp of next. Look at what will happen. If I write this step, what will happen? We will look at here. Temp of next not equal to null. What is temp? Is consists of 100. 100 of next is what? 200. 200, what is the tail value? Tail value is 400. 200 is equal to 400. No, 200 is not equal to 400. Even they are saying that one. So this condition is true. If this condition is true, what are the statements which are there in the while loop need to be executed? We have written only one statement, so that's why the curly braces are optional. If you have more than one statement in a loop, then curly braces are compulsory. Okay, so temp is equal to temp of next. So temp of next is 200 that you are assigning to the temp. Now this temp pointer is pointing to the second node. Okay, again you will check the condition. Temp of next, temp is now 200, 200 next is 300. What is the tail value? Tail value is still 400 only. 300 is not equal to 400. So this condition is true. If this condition is true, you will execute temp is equal to temp of next. Temp is 200, temp of next is 300 that you are assigning to the temp. Now temp pointer is pointing to this node. Okay, again you will check the condition. Temp of next, temp is 300, 300 next is 400. Okay, they are saying 400 not equal to 400, but in mathematics 400 is equal to 400. So this condition is failed. If this condition is failed, it will come out from the while loop. So now temp pointer is pointing to the last but one node. So we want to reach up to here, we have reached. There is a pointer which is pointing to the last but one node in the circular linked list. So now what are the steps we need to follow? We can write, one is that temp of next is equal to head. If I write, what will happen? Here 100 will come, am I right? Temp of next, this one is equal to head. What is the value is there in the head? 100. That will come. Now there is a link from this node to this node, but still this link is existing. This link has been down. Now this link is existing. So how you can remove this link? You can write tail of next is equal to null. Is it clear? Now here null value will come. Okay. If the null comes here, this pointer is not pointing to any memory location. So this link will be down. Okay. This link is down. This link has been down. Now this node is idle. You can release the memory. How can you release the memory? You can call free of, not temp, sorry, free tail. Why I should write tail? Because this node is pointing by the pointer called tail. So you have to give the statement called free and the pointer name which is pointing to this memory location 12. So now this memory has been released. Now this tail should be pointing to which node? Last node. Now this is the last node, am I right? Now tail is having 400. That 400 address memory is not there. Now it is following a dangling pointer problem. Am I right or wrong? So what are the next task we have to do? Now tail should be pointing to this node. How you can write? You can call tail is equal to temp. What is temp? Is consists of 300 that you are assigning to the tail. Okay. That's all. Now this pointer is pointing to this one. Okay. So it is now still acting as a circular linked list. So our headache is solved. Is it clear? Are you able to understand? If you still want to understand, let me discuss another example for you. Now again the user has called the delete at the end. Again you will check the condition. Head is equal to null. What is the head consists of 100? 100 is not equal to null. So this condition is failed. If this condition is failed, this statement will not be executed. It will come to the else block. You have declared a pointer called temp and you have assigned the head value. Now temp will consist of 100. So which is pointing to this node. Then you have written while temp of next not equal to tail, temp is equal to temp of next. You know that it will be pointing to the last but one node finally. So temp will be having 200 after executing these two steps. Then temp of next is equal to head. This is temp of next will be what? 100. So here 100 will come. So this link will be down. There is a link like this. Is it clear? Then what you have done? Tail of next is equal to null. Tail of next, this 100 we are replacing with null value. So now it is a null pointer. So it is not pointing to any memory location. So this link will be down. So this link is down. This link has been down. Now you can release this memory. You can call free of tail. So this memory will be released. Now the tail is acting as a dangling pointer. But the tail should be pointing to the last node. So we have written a statement called tail is equal to temp. What is the address which is there in the temp? You are assigning to the tail. So now tail pointer is pointing to the last node. So the work is done. Is it clear? So this is the way you will delete the nodes at the end from the circular linked list. Now we will discuss how can we delete a node from a circular linked list at a specified position. Okay. Is it clear? Again, let me write the diagram or the representation of a circular linked list. Okay, 4 nodes are there, 100, 200, 300, 400. Don't assume that in a circular linked list only 4 nodes will be there. Okay, just for your understanding, I am drawing this diagram. Address of the next node will be 200, address of the next node will be 300, address of the next node will be 400, and address of the next node will be 100. If it is a single linked list, this node will have the address which will be null. So this will be the last node. But as it is a circular linked list, it will be pointing to the first node. Now you will have 2 pointers. One is head and another one is tail. Now head will be consists of starting node address and tail will be consists of last node address. Okay. Now look at here what we have to do. We need to write the user defined function called delete at specified position. Let me write it as delete POS. Okay. This entire one is a single word. Okay, we should not have any spaces in the variable because even this function is a one identifier. So you should follow what are the rules you are following for an identifier. We should not have any white spaces. So it is a single word. Okay. Now what are the things I need to do? I need to declare one integer variable called POS and another variable called I, and I will assign value 1 to it. Okay, then I will ask the user to enter the position because he need to specify from which position he want to delete the node. Suppose let's take that user has said he want to delete the node at the second position, so you need to delete this node. If user says 3, you have to delete this node. If user say 4, you have to delete this one. If user say 1, you need to delete this one. If user say 10, if you have a circular linked list with 4 nodes, how can you delete the 10th node? That is not possible. Am I right or wrong? So you need to ask the user to enter the position. Then you need to read it. As it is an integer, I am using a format specifier called %d and I am writing ampersand POS. Okay. Now I need to call the user defined function called length. Already I have discussed in the last video how to compute the number of nodes in a circular linked list. If you did not watch it, I request you to go back and watch that one, how this length function will work. Okay, so this length function will count the number of nodes and it will return an integer value. That value I am storing in a integer variable called count. Then I am checking if position is greater than count, then I am displaying it as invalid position. Invalid position. Something you need to display to the user. If user has entered the value 10, then deletion is not possible. So you have to display that invalid position. Then user will understand, okay, whatever the position I have entered, those many number of nodes are not there in the linked list. Then he will give a correct position or correct value. Else, if this condition is failed, what I have to do, we will discuss now. Okay. What I have to do, I need to declare one pointer of strut node temp. I need to write head and then I will declare another pointer called temp1. Why we need 2 pointers, I will discuss for you. Now let's take that user has entered the position value is 2. Are able to understand? Meaning is that you want to delete this node. If you want to delete this node, what are the things you should do? You should write the address. See, the previous node should point to this node. Am I right or wrong? Is it clear? So here you have to write the address as 300. So this node will be pointing this one. Then you can release this one. Okay, then task will be done. Okay, so if you want to change this value, which is nothing but, suppose let's take that there is a pointer called temp here. temp of next should be what? This pointer of next. Is it clear? So we need two pointers. So how we can do it is that we have declared two pointers called temp and temp1. Okay, and temp I have assigned with head. Okay, temp is having the head. Similarly, we have declared another pointer called temp1. It's better you initialize it with null, because this pointer will, if it does not assign any value, it will have the garbage value. Is it clear? It is a problem. So it's better you can initialize the temp1 is equal to null. Due to space issue, I'm not writing, but however you can write it. Anyway, for your understanding, let me initialize it with null. So now temp1 will consist of null value. It will be a null pointer. Instead of a dangling pointer or wild pointer, it's better to be a null pointer. Okay, now we will discuss what are the things we have to do. First thing is that, suppose let's take that user has entered the position is equal to 3. Let's take that user has entered the position 3. Now you need a one pointer pointing to this one, you need another pointer pointing to this one. So what I will do is that while I less than position minus 1, okay, then what you need to do is that you need to write temp is equal to temp of next. Okay, I plus plus. These two statements you have to write if this condition is true. Let me discuss how it will work. I initially having the value called 1 and user has entered the position is equal to 3. Now you check I less than position minus 1. I value is 1. Position value is 3. 3 minus 1 is 2. So 1 is less than 2. This condition is true. If this condition is true, temp is equal to temp of next. Temp is having 100. Temp of next, 100 of next is 200, that you are assigning to temp. Now temp will be consist of 200, which is pointing to the next node. Is it clear? Are you able to understand? Then you are incrementing the I value. I plus plus we have written. Now I value will become 2. Now again it will check the condition. 2 less than 2, because position value is not updated. Position value is still 3. 3 minus 1 is 2. So what is the I value? 2. 2 is less than 2. No, it is wrong. 2 is equal to 2, but they are saying 2 is less than 2. So they are wrong. So the condition is false. It will come out from the while loop. Once it comes out from the while loop, you have a pointer pointing to this node, but you need a pointer to pointing this node also, so that you can release this node, because you want to delete this node. Am I right? So what I have to do is that I will write a statement saying that temp1 is equal to temp of next. Now look at what will happen. Temp of next, temp is having 200, 200 next is 300, that you are assigning to temp1. Now temp1 consists of address which is 300. So this node, temp1 is pointing to this node, temp is pointing to this node. Now what are the things we have to do? First thing is that here it should have the address of this node. Am I right or wrong? Are you able to understand it or not? So what I will write is that temp of next is equal to, this node address is what? 400, where it is having temp1 of next. So I will write temp of next is equal to temp1 of next. Please look at here. In this position, okay, you want the address of this node, because if you delete this node should point to this node. So this value is 400, where it is temp1 of next. So you are assigning 400 value here. If you assign 400 value here, this node will be pointing to this node and this link will be down. Okay, then you need to remove this link also. Am I right? So how can you remove that one? You will write, I hope it is visible for you, or let me write it here. I will use this space. After this statement you can write temp1 of next is equal to null. What is temp1? 300. 300 of next is this one. you are assigning value null here. So this link will be down. Okay, are you able to understand? Then you can call free function and you can give the pointer which is pointing this one. What is the pointer pointing to this location? temp1. So that's why I have called free function and passing the parameter as temp1. Then this memory will be released and then it will become as a dangling pointer. So what we can write is that temp1 is equal to null. Is it clear? Are you able to understand? Let me close the else. Let me close the function. Okay, so this is the way you can delete the. So now what is happening? This node is pointing to this one because address of next node is 400. So which is there, it is pointing. So still it is a circular linked list. So this is the way you will delete the node from a specified position. I hope you have understood how can you delete a node from a circular linked list in the beginning, at the end, at a specified position. If you still have any doubts related to the deletion, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.